everybody, and welcome to another E5 podcast. I am your host, Paul Meenan. Welcome to this show, and I am joined as always by my tag team partners. Introduce yourself.
Hello, I'm JW.
It's Dave Watts here, Sparky Ninja.
Hi, it's Davod Betteridge.
And we are joined by the better man, Betteridge. Two Davids and a JW. This could get confusing. So from now on, you're just Ninja Dave.
No worries.
Right. So today we are going to talk about something that's kind of winging, but also not winging. It's kind of, I wanted to discuss, because we've done a few brain melters, so I thought, why not continue with that? One of the things I'm seeing, or one of the challenges I'm seeing, engineering logic, or engineering reasoning, problem solving, common sense, whatever. People say that common sense isn't common anymore. So I thought I'd knock some slides up to discuss it, because slides give us structure. They give my mind structure anyway. So I thought I'd go through it. Maybe we could discuss some challenges and some stuff. None of this is pre-planned other than the slides. So the commentary, who knows? So do we have any updates for anyone, by the way, other than the fact I'm going to America soon? No major updates, have we?
No,
I'm
just working myself to death at the moment.
I know how you feel.
Trying to catch up with myself, but hopefully I'll get a break soon.
So it's probably worthwhile saying that this will probably be the last podcast for a while.
A few weeks.
Yeah, a few months probably. I think we'll take a summer break until something else kicks off, like the next edition of the Wire and Regs or something else. But we will be back, but we don't know when. So don't cry, don't moan. It is what it is. But what we come back with will hopefully be good and useful. Right. So for those listening on Spotify, which now does video, which is strange, I'm going to share my screen and we're going to display a little thank you ChatGPT for the image. So yeah, engineering logic. What is it? What are we going to talk about in engineering logic? If my computer works, I'll tell you what we're going to talk about. So if you ask the interweb, it will give you this funny image, and it will say engineering logic is central to many things, but it can be broken down as quantitative analysis, which is applying logical methods to evaluate feasibility and effectiveness, problem solving, breaking down complex problems into manageable components. It's an iterative process, refining and improving designs based on logical feedback. It involves communication, conveying ideas and findings clearly to stakeholders. Engineering logic uses reasoning, using deductive and inductive logic to make informed decisions. It involves a system design, engineering systems function as intended and meet requirements, and also testing and validation, developing and executing tests to ensure performance. Now, I think that sucks.
Yeah.
It sucks. It's cold. It's not humanic. It's just, yeah, okay, there is that. They do definitely constitute, analyze, problem solve, communicate, be logical, have reason. Yes.
I mean, it's probably right. It's probably right, but when you put it in words like that, it goes cold and unrelatable.
Yep. Don't trust the internet, folks. I kind of like this bit of a clearer breakdown. So engineering logic is the systematic application of scientific and mathematical principles or common sense. It ensures consistency, rationality, and adherence to standards, which is really important, especially for what we do. Most people will know, me as this emotive, rambly lunatic, whereas John is a cool, calm, collected, focused man. Not much difference between us two, but huge difference between us two. I think that's fair to say. It also forms the foundation for decision making in engineering. That's the thing. When I'm at work, some people will say I'm an emotional lunatic or I'm an emotional wreck. I'm very, very, very cold when it comes to decision making. It's objective, factual, not feeling derived. My outward emotions may be feeling derived, but the actual decision making can't be. What's the phrase? Facts don't care about your feelings. That's one of the modern phrases used around. So that's engineering logic. Engineering reason evaluates and refines ideas based on logic and experience, which I think we as electricians and electrical engineers use reasoning a lot. It uses deductive and inductive reasoning to analyze problems, and it's critical for assessing alternative solutions. Is there another way of doing this? Is there another way of grounding this cable, doing this trunking, doing this board? Setting out is an engineering reasoning thing. How do you set out electrical installation to ensure your cables bend and your switchgear has the space around it and stuff? Problem solving, well, that identifies issues and develops practical solutions. I think most good electricians are problem solvers. It uses engineering logic and reasoning to address challenges, and it's essential across industries and professions. So most of us are problem solvers, I think. Or would anyone say that there's a lack of problem solving in our industry, or have we become too reliant on standards? What's your thoughts?
I think over the years, people have, I guess, people have got less experience, or there's been less opportunity to have the time to develop a deeper thought of understanding, and it's become more economical in many cases to just replace things. So the ability for electricians to actually fault find in an electrician role is a lot less often, unless it's obviously a wiring problem, such as cable faults and circuit faults. But most often it's just it don't work, rip it out, replace it. Whilst in the maintenance sector, that's where I work a lot with engineers in the maintenance sector, and those guys like to know how things work. They have to get things working. They have a very wide range of skills. But as you say, adhering to standards is one of those things where if we have the ability to actually develop an understanding on the wider range of standards, then we'll hopefully get the ability to put the time in to actually work to those standards. But that's where we do sometimes see that we have a lack of engineering logic because people don't understand the full spectrum of what they should know.
Yep. Leads me on to common sense. Common sense, not very common, but ensures practical and feasible solutions in real world, helps avoid unnecessary complexity, and balances theoretical with real world constraints. The standard says this, I can't achieve it, which is why we always say don't be afraid to depart from a British standard because they are a consensus of opinions of experts. Doesn't mean you have to follow them. John, what's your thoughts on all that before we move on?
Yeah, on the thing about complexity particularly, it's also about not increasing the cost of whatever you're doing to some outrageous level. Because, there might be a solution, but if it's going to cost 50 times more than the alternatives, well, why would you even bother? Because somebody's paying for that in whatever sector it's in, and particularly in domestic. If you go to someone and say, oh, yeah, we can do all this, it's going to cost 10 grand or something, or we can do this, it's going to cost 50 quid. No one's going to pick the 10 grand option. They're just going to tell you to leave and they'll get someone else to do it cheaper. So, think about the choices you've got.
Yeah. I'm thinking on the lines of what Dave kind of does. Have we lost our engineering logic through sort of the way it's being taught these days? As multiple choice sort of ended our kind of logical reasoning in written exams, and the way it's done now maybe doesn't allow an engineer to, when they're learning, to develop an engineering logic and judgment.
I never thought of that, and you're bang on. Multiple choice exams, they remove that reasoning, they remove that ability to logic. Let's be honest about it, I know people have literally gone ip, dip, dog, bleep and picked an answer.
I mean, add to that in recent years, a lot of Sparkies just they don't think that they need to know. All they need to do is call their common person scheme and find out what their guy says. And we see that all the time. My guy said this, my guy said that, and they just worry about what they will require. And that means that they, the engineering logic or the ability to actually find the reason, they don't even do it. They pass it over to a CPS or an advisor, and they just look for the yes you can or no you can't kind of motion.
There's a weird reliance on that, isn't that? You're right. My area engineer, my this, that, and the other. And the thing is not taking anything away from air engineers, but I'm sure the air engineers can't stand getting constant phone calls from people who don't know what they're doing. You know what I mean? They don't want to be a tech helpline. They just want to do their assessments and go home and live their life. But yeah, one thing also, Dave, you mentioned, I think is really important, worth noting, is the skills that we had and we don't have now. Perfect example was when I was younger, I went for a job interview where somebody said, oh, there's a three-phase motor, can you rewind it? And I had to say no. And the reason why I had to say no is because one, it weren't in the curriculum, two, it weren't in the syllabus, and three, it's cheaper to just buy a new one than it is to spend the time rewinding the motor. That's the mindset.
It's just cheaper. But when you've got that one motor that you can't source anymore, or you've got that one issue, you then find out that you haven't got the resource or the ability to keep the equipment in service, because we've all got down this angle of it's just quicker and more economical, as John says, to just price the replacement over putting in the engineering time to fix things.
Yep.
So over the course and effect, with the way the economy works, it appears that engineering as a mindset of people in the field, it's much easier just to replace things.
Yep. And it then becomes detrimental. You're kind of shooting yourself in the foot by you're contributing indirectly to the de-skilling of an industry, whether you realise it or not. I wish more people would realise that their actions contribute towards de-skilling. Perfect case in point is clients who won't pay for apprentices. Those
True.
apprentices are the future of those contractors and the future of your supply chain. And in 20 years' time, clients will go, there's no skills. Yeah, because you wouldn't pay for the companies to have apprentices. Hello? Vicious circle. But anyway, how these elements work together. Engineering logic provides a structured framework. Engineering reason refines the decision making within that framework. Problem solving applies these skills to real world challenges. I prefer to be a problem solver or reasoner. And common sense assures solutions are practical and applicable. I call myself this many times, where I am a farmer of common sense. There is my fields, and watch me sow common sense throughout it. Because once you understand what we're going to go through in a minute, then hopefully it will help your engineering reasoning and your logical skills grow. So one of the things we all get asked, how can I learn better? How can I prepare for exam? How can I improve my career opportunities, my chances to grow within my relevance part of our wonderful industry? Really simple. Learn the law. Learn the law. There's only one law you got to learn, which is Health and Safety at Work Act. Section 2, Section 3. If you memorise them, you'll probably know just as much as most health and safety advisors. And that's the general duties to provide a safe workplace, safe equipment, safe access and egress, etc. They're the things that people are prosecuted under. Regulations. Well, for us, the only regulation we need to understand, electricity at work regulations. Because that's the subset of the Electricity at Work, the Enabling Act. Equipment fit for use, Regulation 5, earthing, Regulation 8, etc. Isolation, blah, 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 blah. What's our defence under 29? Standards, BS 7671, BS 6396, BS 4619, and all the other stuff that we've just covered. Research, white papers, IEEE websites, there's universities, all sorts. We can experiment and analyse with, like, you guys like building rigs, and we've got lots of rigs, diverted neutral current rig just behind me. Experiment, analyse, look at different causes and effects. Look at white papers that are available. White papers are independent research. So in theory, I could write up the diverted neutral stuff into a white paper. I'm not. I'm writing a book for Electrical Safety Roundtable, which will hopefully be out in the summer. And that will be like the cumulative guide of everything ENA, UKPN, ESQCR, 767, all of it in one-stop shop, so that we've got a foundation to grow from. While the rest of the industry completely denies that diverted neutral current exists because nobody wants to report it. Behavioural problem in industry there. Reputational problem in industry trying to get it reported. So Mr. Skirm, God love him, he's the one who always says no, no, no to everything. And we've sat in many a podcast and came up with stuff, and he's quite happy to rip the giblets out from under us, regardless of what time of night it is. And he'll always say to you, you've not researched it, you don't understand it enough, you need to understand. You shouldn't really be afraid of frustration, because today I've spent all day writing this book. I'm about 24 pages in. It will be about 50 pages before it goes off for finessing. I expect it to probably be 60 or 70 when it gets published on diverted neutral. So one of the things that I struggle with is being calm. Logical I can do, use facts, no problem, lots and lots of reading. And then use your feelings, which people hate, to drive your pursuit of knowledge, which we're all guilty of doing.
I like that last one. Yeah.
It's true, though. Most people at work will think I'm some sort of mad lunatic looking at electrical things, but I know what I know and I don't know what I don't know.
I get the same kind of comments my way with regards to the ambition I have in training. You try too hard, you do this too hard, you don't need to cover this, you don't need to do this. And it's just the ambition to actually share knowledge and get people to think better about what they're already doing. You get kicked all the time for that kind of ambition.
Anyone who kicks me, I give them two options, because that's who I am. One, go talk to that tree, or two, go speak to a brick wall. And if they want a third one, I tell them to write down all their thoughts and feelings and send it to PO Box. I don't give a fuck.
Mm-hmm.
Simple as that. I'm not changing who I am for anyone. Simple as that. Right. So this wonderful little table we've had this for about 7 or 8 years now. Something I knocked up ages ago, and then Mr. Skirm expanded on even more. And it's about how you understand, manage, control the expectations of that duty owed. When I talk duty owed, it's always your legal responsibility to discharge the Health and Safety at Work Act. And doesn't matter what regulation, whether it's CDM, EAWR, whatever, the duties owed are to protect yourself and others and all that jazz. So what I did was I used that Maslow's hierarchy of needs, and I just created a very simple Janet and John visual to help me explain, and we've used this in previous podcasts, that line of sight. So if I'm at the bottom and I'm reading my ECA guidance note, or I'm reading my NAPIT Code Breakers book, what journey upwards to the courts will I see? Well, the first logical step is the IET guidance notes. Then you've got the British standards. British standards are obviously guidance as well. So you have at least 3 layers of guidance, at least. Then you've got the harmonised documents, ENs, BSEN standards, that European centralised stuff. You've got secondary acts of Parliament, which is your regulations. So I know everyone thinks the IET wiring regulations are regulations. They're not. They're a guidance note. The story behind that was they couldn't decide on a title between IET wiring regulations and requirements, so they kept both, which is why the IET wiring regs has got 2 titles.
Mm-hmm.
And that's from somebody who retired at the IET years ago. And then you've got the acts, and you haven't got that many acts. You've obviously got the Equality Act, so that's the requirement for reasonable adjustment to be made for persons of reduced mobility and people who meet the protected characteristics, which I do think have gone bonkers in this country, by the way. We like reasonable adjustments doesn't mean you spend £1 million, but then to make it Equality Act compliance, you spend 10 more. That's not a reasonable adjustment. Yes, and then you've got UK Acts, obviously Health and Safety at Work Act, the most important one. And then above that, because we're out of Europe, but we're not out of Europe standards-wise, you've then got the essential health and safety requirements of the LV Directive, Machinery Directive, EMC Directive, and any other directive you like to shake a stick at. If you understand that logic, that hierarchy of what the structure is, you're halfway there to understanding and creating a good mindset for making decisions. The most important thing is, as we've said all along, is those top 3, the EU directives, acts, and secondary acts, are all free. The reason they're free is because they are the things you'll be prosecuted under a court of law and be used against you. The wiring regs and other stuff might get used, but if you can depart from it, they don't really matter that much. Was the equipment fit to be put into use? No. Regulation 5 EAWR breach, free. Section 2 breach, done. That's enough. Huge fine, go to prison, whatever. So it's really important that if people can find a different way, please find a different way. But that's my way of visualizing that. What do you guys think of that before we move on?
The thing is to remember that a lot of the things that we do get told to invest in, or we're expected to invest in, such as, if we're working in this industry and we purchase certain publications, or we do certain courses, even like AP training or AE training, they're just routes that are somewhat definitively written to serve a certain area, but they're just routes to serve what's free in the blue there. They're just ways to comply with the actual statutory instruments and the actual legal requirements. And so a lot of the stuff that we're told we need to have, we just need to sometimes just look at the actual end goal, and it's just to comply with what we can obtain for free. But they're not obviously sold to us that way. They're told we have to do this, or we should review this, or we should get that. But if we look at the end goal, oh yeah, it's to align with this, we could just go straight to the free stuff and fully translate its requirements.
100%. And the thing is it's like if you are working as an engineer, you just need to be sitting there thinking to yourself, okay, well, I need to have a defense. Even the electricity at work reg says defense. For fire safety order says defense. If you have a defense, you have an engineering logic, which could be, this book said that, I didn't want to do that, so I took this guidance and I used this applicable. And if you've got that engineering logic in your head and you're happy to stand in front of a judge and say, well, this was the decision-making process I made, this is how I documented it, this is how I communicated it, you probably logically got you have discharged your duty of care to those persons above you. and then you have a defence.
I said exactly the same thing in the meeting last week. I'm the chair of a steering group for one of the UK's biggest food manufacturers, and we had 8 engineers from their factories all around the UK in this meeting, and we're just trying to conclude the outcome. And I translated exactly what you just said there about defence and about the legislation. Once they understood exactly what our objective was, they found it so easy to look at their journey as to what they had to achieve instead of complying with this, complying with this, complying with this, complying with this. When they knew what they had to achieve in the end goal, they could easily get there. They just weren't told where the goal was.
And that's the thing. If people learned key regs like Section 2, Section 3 Health and Safety at Work Act, defence regulation of electricity at work regs that says that person must take all reasonable steps to avoid commissioning of an offence. Okay, well, if I know what the legal general duties owed under the law, and I know I have to take reasonable steps, and I know what I know, now if I can't fix the problem, I have to discharge that duty by taking a reasonable. So for me, one of the things I've done over the years at work, if I've hit a brick wall, I've had to write a very non-technical but very concise email to my directors and say, at the bottom of it, I hereby have discharged my duty of care under Regulation 29 EAWR and have such taken all reasonable steps to avoid the commission of offence under Section 2 and 3. Boom. The minute the safety director reads it, what do you think happens? Money appears, things change.
Well, that's the thing, isn't it? You report that up, but then you obviously offer, when you report that up, solutions of choice. So you don't just say, we've got a problem. You give them solutions of choice, normally the economics of it.
Yep.
And then they now own the duty of that.
Yep.
And then you have the Corporate Manslaughter Act come in if they choose connivance or just to not do anything with that information.
So one of the things that kind of we want to talk about as well in that engineering logic, because at the moment what we've done is we've just gone through a hierarchy of standards. Now, lots and lots and lots and lots of people get confused. When you say standards, they immediately look at 9001 alongside 7671. New. So ISO is International Standards Organization. They write management standards, process system-based standards, not technical engineering standards. And it's really worthwhile clarifying that. We'll go into that a little bit. So there are two big standards organizations. Obviously, the ISO are recognized globally. The IEC are the International Electrotechnical Commission, and they write their IEC 60364s, which eventually become BS 7671. But the two are different, and their intents are different. And as a good engineer, when you're making your engineering logic, your engineering reasons, you have to be able to say the technical requirement or the technical guidance to meet the intent of law of this is this, and the ability to manage it and control it is a separate thing. So if you're trying to add weight to your logic, understanding the management requirements and the technical engineering requirements in parallel make for a very, very robust argument. Because you're not just looking at one group of engineers consensus, you're looking at a global set of engineers and management consensus of opinion, which then makes your argument really, really strong. So the reason why you have to have a strong argument is this wonderful Paul Skirm table, which, to be honest with you, blew my mind when he first did it. I think he was where was he when he did this? Was he in hospital when he did this, or was this before he went to hospital? I think he wrote an article on machinery, didn't he?
He did a lot while in hospital.
Yeah, he wrote tons. He did loads. So basically, if we look at the table, so we've got Maslow's triangle again, but he flipped it from the technical standards to the psychological, the human factors, which is really important because we can create standards, we create management systems, but we can't create Borg drones. People are not computers. They're humans with emotions, and they're very unpredictable. So Paul used to say, well, if we look at the top of the pyramid, Health and Safety at Work Act 1974, 100%. Under that, you then got other secondary legislation, the AWR, PURE, and all the other machinery directives. Then you've got those harmonised standards, the ENs, the HDs. Then you've got the health and safety executives, ACOPs, etc. Then you've got industry guidance from whatever source you might, and then the customer requirements. Right at the bottom, underpinning all of it, a customer has ordered this. And basically what the point Paul was trying to make was the volume of available and the requirements of machinery or electrical systems. So I want you to go and replace my machine and rewire my shop. And they don't understand when they create that baseline criteria, that the stuff above it is what shapes the work, which is huge. And engineers need to know this, but they don't. And this is the thing. The law, if you flip that, the law will see the most important thing, on the left is the customer requirement. I want this. I don't care what you do. That probably creates the race to the bottom, because those who don't know don't care to know, because they'll just do it cheap. Whereas the one on the right will then how the law will see it. So the most important thing is the law will say is the Health and Safety at Work Act, then the secretary legislation, then the harmonised documents, then the codes of practice, then the guidance, and then the customer requirements. So a big FU to the customer. Whatever you're doing, you're going to comply with the intent of the law. It's the same vision, but two different ways of looking at it. And it really does, it's a good stopgap to be able to say, before I write that email, before I have that conversation, before I do that presentation, how will the other people see it? So, for instance, Mr. Betteridge, if you go into a meeting and the health and safety executive there, you're going to sit there and start off by going, well, the customer required this. And they're going to be sitting there going, yeah, all right, mate, behave. What you should be going is, well, there's a general duty owed of Health and Safety at Work Act. And we understand that. And then we get to the customer requirement. They'll probably sit there and go, well done. It's that almost holding a mirror and seeing an alternative universe version of yourself. Lots of Star Trek references in there as well. So yeah, it's one that's worth. It's that pause moment.
It's like we always go, oh, the client don't want to spend this, the client doesn't want to do this. So we need to remember that, as much as we may want to try a job that is economically accessible to the client, we can always give them the right information and get a cost-effective way for it to be delivered. If we sacrifice it and make that really bottom part wide for the customer to get all their expectations, whilst we may say we're not owning the whole thing, and truly clients will have a client who runs a business will still have the duty themselves for their employees at work. But what we want to try to do is, instead of have it a triangle, you want to try and keep it just like a big rectangle all the way up. So you meet their expectations as best you can, but you actually point them in the direction of what you're saying, actually point them to the legislations that they're, that they're duty to try to widen up the top of the pyramid, fatten it up at the top, so they can then realize why what you're saying is actually necessary. And it's one of those things that we've said before about, when we covered like the regs and the electricity work regulations, trying to get clients to understand that this actually is a statutory requirement, trying to get them to see how fat the top law part can be, but also try to get them to see the benefit of it. It's a very tricky thing to do. It's something that I've had to do many times. Most of the time I get contacted because something's gone wrong and they need a consultant to come in, and they have to look at actually how big the top of that pyramid should be, where they look at where the laws were infringed. But it's a really great way to think about it.
There's a general assumption that people are compliant all the time when they're just not. I've worked for loads and loads of companies where they're just not compliant. They don't meet most of the essential health and safety requirements. When you look at secretary legislation, they're actually non-compliant, but they hide behind management systems.
Yeah, exactly. And also, as you said earlier, though, you don't know what you don't know. So you need to employ the services of people that help widen your understanding of what you need to know, such as things like arc flash risk, as a good example about, you have people coming into work, working on an energized or stored energy system with no understanding of the value of energy that could be released during their work. If the electricians don't know this, and how will they know this? So they need to explore and look at these other resources. The HSE has it all there. They just have to have that inkling to look for it. And a lot of the HSE stuff is written for the companies, not for electricians.
Mr. Ward, your thoughts?
Yeah, you've got to be careful there, because, so on the left one, I mean, customers, they want everything for themselves, basically. They're selfish kind of attitude, really. But you've got to be careful and not just sort of accepting, oh, we want this, so just go and do it, because otherwise it's not going to be compliant with any other stuff up there. On the other hand, you can't go too far the other way, because if you say, oh, well, this, and the rest of it, and we don't give a stuff what you want, well, you're not going to be getting much in the way of work either. So, yeah, you need some kind of balance between the two. But definitely, expectations of people, what they think they should have, do have to be altered in many cases, because what they actually want and how they want it done just isn't going to work. So it collides to everything, really. You've got to make sure that they get an end result which they're happy with, but not necessarily what they initially wanted or how they were going to do it.
Yeah. I think for you, what you need to do is you look at the triangle and you go, right, well, what they want is it to cost this much. You disappoint them. You say it's going to cost a bit more than that, but at the same time, you say you narrow the bottom, but you widen the top. You see, as you then tell them, and that's what you want to do, is you want to actually make sure that you can communicate that to them, and just not, listening and letting them be in charge of everything you do as an output.
It's a very logical point. One thing I will say as well, and add to that, is there'll be a lot of electricians, a lot of companies going, well, if I don't price it at this, I won't win the work. I won't be able to do the work. Don't.
Yeah.
If you know that the work is going to be dangerous or cost more, and you know that in advance, what's your defence in a court law? None.
Yeah. And at the end of the day, if you put the extra bit of work in to just read a bit more resources, have a wider angle of opinion on these things, and you speak correctly to your customers will know the value of you as the person they contact.
Yep.
And they'll see the credible value in that, because they'll understand that you're actually doing the better job for them, and then you'll find the customers that you really want.
Yeah, on the pricing thing particularly. I mean, if you certainly for domestic stuff, there is that temptation to think, oh well, someone down the road priced it for 500 quid, so we can't possibly do more than that. But the thing is, you've got to explain to them what's actually needed and what they're actually going to get for it. And yeah, that person down the road might be cheaper, but the thing is, there's a reason why they're much cheaper, because they're not doing half the stuff that you actually need. And if you actually explain this to people, a lot of the time they think, oh well, yeah, that's obvious, and then they think, oh, that bloke down the road is cheap, a load of old rubbish, so I'm not going to use him. And then you actually get it done properly, and they pay you a decent amount of money as well. So yes, it does work. And of course, there's going to be people that, if you tell them it's going to be more, think, oh well, never mind, we'll just go with a cheaper person. Well, so what? Carry on then. Do we care? You want the cheap rubbish? Well, you know exactly what to do. And then they'll call you back in 3 months' time saying, oh, that person we had in did it all wrong and it's all broken. And can you come and fix it, please? And then it's like, well, you want to pay up for it. You know what to do, don't you? But don't be afraid of pricing things at an appropriate level and including all the stuff that's actually needed. You're not competing on price, particularly. You're competing on doing it properly compared to someone who's not.
Yeah. And at the same time, there are different ways to do these things to the way that the industry does it. It's like if someone contacts you to do EICRs or even like PAT testing, should I say it, everyone goes, that's race to the bottom, that's race to the bottom. And it truly has, if you do it the way the industry does it, which is by the asset, where you test every single asset and you go to a property, you test every single circuit. Let's remember that if we look at the actual guidance and we look at the publications, we're supposed to inspect and then choose to test to support our inspection. So like with assets of a site with PAT, you can actually go to a site, you can just do a general observation of the utilization of the property, the behaviors of the users, the training that they receive, the environments that they work in. You can then sample products from different environments, and you can give a much better, more detailed understanding on the quality and the way that the client or the duty holder uses their electrical equipment than someone who's ran in there desperately trying to put green stickers on everything. And it's the same with fixed installations. So the way you do the work, you can do it better and still do it in a way that you can afford, and you don't have to test everything to death.
Yeah, I don't disagree. Right, let's move on. Let's look at the large body of standards, the ISO. So ISO, as I said, National Organization for Standardization, although they're called ISO, but the names are twisted, never mind. ISO standards provide structured approaches for quality, safety, risk, and asset management, amongst many others. They ensure consistency, compliance, and efficiency in engineering practice, management practices as well. And they are actually divided into two categories: management system requirements and guidance. So there are lots of people who will quote ISO standards wrongly and say you must comply. No, you don't have to. But then again, with any standard, you don't really have to unless you've signed up to it, which is quite interesting. So just to give you a key indicator of some of the standards. So everybody knows ISO 9001. Quality management, 14,000. Environmental, 20,000. IT service management, 22,301. Business continuity, 27,001. Information security management. You've got 42,001. AI intelligent management.
Wow. Okay.
45,000. Occupational health and safety. 50,000. Energy management. 55,001. Asset management, and 56,001. Innovation management. So just to let everybody know, these standards, if they're a zero at the end, it's normally the introduction to fundamental principles. The 1 is generally the requirements, and if there's a 2, it's the guidance on how to implement it. So there's a lot of them, and I sit on now the BS 55,000 committee, and I'm going to Belgium in May to a plenary to write 55,014. So ISO standards, some of these are guidance. So 31,000 risk management is guidance, it's not a set of requirements. There are companies out there that are trying to get certified to guidance on management systems. So you've even got like 19,001 audit management, 26,000 social responsibility, which I think is now social value, 31,010 risk assessment techniques, 45,003 psychological health and safety guidelines for managing risks, and then risk management vocabulary guide, ISO guide 73. So there's lots of weird, unique. Now the thing is, they're not weird. All of these, like the IEC standards, are the consensus of experts. So I sit on the ISO 55,000 committee, and it's experts in asset management from all around different sectors, different fields, all discussing the merits, the cons of the standard. Could it be improved? The audit of management systems, they feed back into it so that the actual standard itself is improving. I don't know how many electricians feed into BSM 671 as a regular thing, other than, you know, some of the super keen people that we know are out there. And that kind of causes a bit of confusion. So we start off by talking about the health and safety laws and sub-specific guidance and all that jazz as shown in the table. And a lot of people, when they're talking about standards, you can call an IEC standard or an IC standard or GN or British standard or whatever, but management systems standards are separate. They run in parallel. And that's one of the things I kind of trying to get. I'm trying to get across that there's two standards. One is your technical engineering requirements, experts, doers, manufacturers, etc. And then there's just the pure management system process derived standards. So when you're making an engineering decision, if you really want it to be robust, yes, use your hierarchy needs. Yes, understand your legal duties from the guidance all the way through the design, the European standards, the law, etc. But then there's the management system stuff as well. That says stuff that says you'll have policies, you'll review, you'll control records, you'll manage risk, and they're both running in parallel, and they can appear at any point on any triangle you want to do. And I'll kind of come on to that in a bit when we're doing some of the examples. Mr. Watts, this is your slide, so you can go through this one and just introduce everyone to what the IEC stuff is.
Gosh, this is an old one. Yeah. This just illustrates that the IEC is the international committee, as you know, as you've mentioned. 64 is particularly the numbering, correct me if I'm wrong, for the low voltage committee, for electrical installations. They work collaboratively with contributors from all around the world in different areas and divisions, and they produce what's known as IEC 60364, which is basically 7671, but at the nosebleeds level up there. And then that's something that internationally is kind of looked at, and then you then have other local areas. In the case here, we have the European Committee, which kind of sits over the European countries, which I guess we're still attached to from the perspective you mentioned earlier on. Through this committee, Senelec. Do you know where Senelec's based? Do you know what country that's based in? No. TC64, again, technical committee for 64, low voltage power. Produce what's called a HD. It's a harmonized document, 60364. And that is the number, again, for low voltage electrical. And it's an important number. And I say this to guys who come onto courses with me, because when you look in manufacturer literatures, for example, big companies like Schneider, you may see when you look in their literature, they'll say 60364 all the time, IEC 60364. We need to see that number. We need to basically say that that's the same number referencing to 7671. In the UK, we have our more detailed document where we've got the specifics for the UK with our 201 regulations and such. And instead of calling it 60364, it's become the British standard of BS 7671. I don't know why we haven't called it BS 60364, to be fair. But a bit more sense to me. But it's just a process. So ceiling level, European level, and then each individual country. I think Paul, John, and I all possess the Irish one. What's that? ISO
10101.
10101. Looking for it behind me. Actually, it's in my centre. And I actually preferred that as a publication. It has the same information in it, but actually it's a better read.
Oh,
So it is amazing how things are done differently when they produce their local publications. So obviously 767 is a local publication, which is interesting because when you go to other countries, you go like Dubai, etc., they'll mention 7671, but really they probably should just mention 60364, but they'll mention the locality of 7671 with some tweaks. But that's pretty much how that works.
I think the Irish regs is the best written. The American one, the NEC 70, is like reading some weird alien language. And then you read runways and you look at some of the regs and you have to chuckle to yourself because it's slightly crazy. But yeah.
Do other countries kind of use 7671 as their basis because we have like the .200s in ours where we have a little bit extra, or do they not take the 200s into account that we apply?
Generally, no, they don't. The 200 stuff is pretty much UK only, and you won't generally find it anywhere else unless someone else has decided, oh yeah, we need that, and then they'll give it their own numbering in their own standard. But it should only work from the top down.
So, quick question for John: do we know why they called BS 7671 BS 7671?
No, it's probably some historical thing.
They probably should call it BS 60364.
It is strange because everything else seems to align in that way when you look at products.
Yeah.
But I mean, I don't think there's a European or international version of 7909, so I can understand that there's a certain numbering arrangement. But this was, this is basically under 60364. It might change in the future. Who knows? I doubt it, but it's important that we just, if you read a Schneider document or another international manufacturer, they'll likely not put 7671 in there that much if they're writing in one space for international distribution. And as I say, I often recommend those kind of manufacturers over others because they have that legacy, and you can read their the history of what they've been advising.
Yeah, the Schneider electrical installation guide is brilliant. It's one of the best.
It is.
We're very lucky. We've got a hard printed copy of it because it's an epic beast.
Yes, but it is.
If you were ever working in Europe anywhere, I would definitely start with that because it's very good. Anyway, let's compare the key concepts again. So engineering logic gives you structure, reasoning evaluates and refines, problem solving applies logical principles, common sense ensures that things feasible, we can do it, and standards take the form of recommendation and guidance, regardless whether it's a management system or a technical or engineering one. Very important. So the kind of the pros and cons of it all, really. Well, it kind of encourages consistency and rationale decision making, enhances the ability to tackle complex problems, and ISO standards provide structured frameworks, but they don't replace standard requirements and guidance. This is what I was saying. You've got to have dual mindset, two pillars. One is your technical engineering logic, the other is your management. And good engineers have to be, if you're going for professional registration, you have to have your management skills and your reasoning skills as well as your technical. So your A's and B's of your engineering council is about technical problem solving, design, engineering. And then your D's and your C's is your communication, your management. So there's one question about management systems, and when we ask it, we expect the engineer to be able to go, our company has an ISO 9001 management system. Now, I've interviewed people where I've asked them, do you have a management system? And they've just gone, what?
Yeah.
And you know they're failing.
Yeah. See, I have one, so I run a training provider. I haven't got 9001 because I haven't just had the time to put money in that area because I don't really need it. But I have a quality control system and a management system. And so I've got clients, and they'll ask, how I manage quality, how we manage, and that's what a 9001 also does. It's like you go to a large client, they'll have contractors and they'll have contractor control. I remember I went to one large client to do a duty holder audit, and I looked at he had a fire alarm company in the factory, but the factory had sent a subcontractor. So on their system, they had a fire alarm contractor, all of the employees' records, but the contractor actually on site wasn't on their log. So they use these kind of management systems, and if you're in the production world, it's so that you maintain the same thing. As a training provider, if I had a trainer delivering a course for me in Birmingham or down south, you should have the same output of quality. So you have that quality control and you have that management to maintain that quality and maintain that service and maintain integrity, and you build up a big relationship with the company. They want to know you're there for the foreseeable. They don't want you to just disappear in 18 months because you're a new company. So they want that guarantee. There's all these things, all in management, not in how good an electrician you are. So they're all in how you run as a business and how you actually manage stuff.
So moving into the negatives or the cons of engineering logic, or some of it that can happen, I see a lot of over-reliance on structured methods, standards. I'll be honest with you, I see on a weekly basis the word governance used.
Yeah.
We can't do it because of the governance. We can't do it. Well, governance is just a documented set of processes agreed by various people. If they can't change their own systems, what are they doing? What are they doing? So there is a massive over-reliance on standards. Look, let's be honest about it. How many people, Mr. Betteridge and JW, argue over BS 7671 as some sort of cultish Bible?
Yeah.
Yep. And the reliance on structured methods is the old ways are best syndrome. So in other words, it was written down 100 years ago, and you must continue doing that until the time ends, and you can't challenge that whatsoever. And of course, failing to realise that, yeah, they might have been best once, but of course things change, and if your methods haven't changed, well, they're not going to be valid anymore, are they? So
I think the most common one probably mentioned is when a testing inspection's done and the installation was put in at a certain time, and because it was put in at that certain time, it complies now because it doesn't have to comply to the current standard. So there's a belief that a cable that could be old and paper insulated or rubber could just be as compliant today as it was then, just because it was put in at a certain time.
Yep. And you can look at that cable and go, was it installed to any product standard? Maybe, maybe not. Is it regularly inspected and tested? Is it life expired, and what is the ongoing condition of it? Does it provide a level of safety equivalent to modern standards? If not, what's the mitigation? What's my defense in a court of law? Can I enhance that protection? That's the sort of questioning you ask yourself before you apply your engineering codes. Not, oh yeah, well, it was fine when it was installed, so it's fine. You're missing your engineering logic, your engineering reason. We've got a code, so we'll come back on that. So standards can be rigid, unaligned, and slow to adapt to new challenges. Soapbox moment, sorry, but standards, when you get to know them as well as we have over the years, I wouldn't call them rigid, but most certainly unaligned. Maybe the humanity side of people that just adopt them as rigid, and they're certainly slow, because we've been saying for some time now that the standards are massively behind because of technological changes. Anyone got a thought on that? You were all stunned. I'll move on. So the Organization for Economic Cooperation and Development supports ISO standards for international trade. The US EPA recognizes ISO as a key contributor to industry. Governments worldwide use ISO standards to shape public policies. Great. Okay, so ISO standards do all this stuff around the world, but also IEC standards have a global reach. So you've got one set of standards for policymakers, managers, non-technical people. You've got IEC standards for technical people. Even if you're a 7671 user, you're using 60364. The engineers, the reason why engineering is dying on its arse is because the managers and the management systems are overtaking, and the engineers need to understand that management system to make their arguments robust. Okay, that's kind of where I'm getting from for this. There's a diagram for Senelec. I have no idea why that's in, so I'm going to skip over it, but they're all the countries in the EU and outside the EU. Now what we're going to do is go on to some scenarios. So basically, scenario 1, asset manager, no bias whatsoever in this. So a design has been issued, and there's a contract clash on an infrastructure project. There's conflicting stakeholder priorities, and how can engineering logic, reasoning, and problem resolve this? So my question always when I'm at work is if you look at the screen, it says JCT Design and Build Contract or NEC4. So there are two major forms of contract in the UK. And what could you give? Well, let's see if I can find an example. Contractors come in with an early warning. They have designed something and there is an unknown element to the work. So, for instance, let's say they're building a bridge, and as part of their design and build contract, they're only allowed a provisional sum to do geotechnical surveys, or they've assumed as part of their tender that there'll be a 100 amp power supply available. There isn't. So they then raise an early warning. The client doesn't have any extra money. You immediately got then, well, you're designing and building it. You should know. You're a competent expert. You should know. What would you do if I turn around to you, Dave, and I said, you come to me and you said, well, I'm a contractor. There's no power supply for you. There isn't enough capacity. You're going to pay me more. And I'm as a client going, nah. Now you've got to design and build. All the responsibilities on you. What would you do to argue with me? Of a logical discourse to win your request for getting more money. It's a good one, this one, isn't it? John's sitting there going, just get a baseball bat. Just give me the money. Just go violent. Come on. What are people thinking now? Or would you like me to solve this one?
Everyone's got so quiet. So
okay, I'm going to solve this one. Right. So two mindsets here. The managers, ISO world, managers not being technical, thinking contractors just taking the piss. He wants more money. That's a bad client. Just to be clear, if a change is a fair and reasonable change, so under the NEC, every single contract starts with, this contract will be delivered in the spirit of mutual trust and cooperation. It's fair enough. So I've gone out as a client and I've asked three contractors, Dave, and John, build me a new, I don't know, let's say it's a amusement park. And so you've gone and said, yeah, I can do that. I can build an amusement park. I'll put in all the distos. I'll do all that. I just need a power supply. And as part of your tender, Mr. Betteridge has allowed for a 100 amp generator. Mr. Watts has assumed there's a 100 amp supply. And JW has said, there isn't, but I'll build you a transformer. So three different bids with, this happens, by the way, three different bids with different ideas. And the client says, yeah, Mr. Watts, I think you're the cheapest because you've assumed it's there. Great. Well done, Mr. Watts, you've won. Because Mr. Berridge wanted 10 grand for a generator. Mr. Ward wanted 100k for a substation. So you can do one. Okay, well done, Dave. You've won. So you turn up, you're building your thing, and you're going, there's no power supply here. I thought there was one. It's a little 16 amp socket. It's not 100 amp. I need 100 amp. Otherwise, this 16 amps just going to melt. So you will come back and you will engage the contract. So you will use the contract. So most projects fail because people don't use the contract correctly. So you can argue under the contract, I'll call it a Z clause. I had allowed in my original tender clause 4.0, we assume, one of your assumptions, there is suitable and sufficient power supply. So you write to me with an early warning, because that's the term used in the NEC. And basically you say, we assume there was a 100 amp supply available for connection. There is not. Please receive this early warning as there will be a time and cost impact to completion because I can't switch it on. Please can you give me a variation order or an instruction to go and get a 100 amp supply for the avoidance of doubt and the spirit of mutual trust and cooperation. Here is a quote for a 100 amp supply from the DNO. It's £20,000, which is a lot cheaper than what John wanted and a little bit more expensive than what Mr. Betteridge wanted. Now, as a client, I'm trying to control change, control cost. I don't want to do that. I'm now at loggerhead. Damn. Okay, so what's going to happen? There's going to be reputational damage. I won't finish my project. What if I just say, well, just plug it into the 16 amp? To hell with it. Yeah, because I'm the client. I can do that. I just tell you to plug it in. So you're now at a problem because there is a source of energy, regardless of what the limitation is. You need to add weight to your early warning. So you need to turn around and say, right, as well as not having suitable and sufficient power supply, the requirements of BS 7909 is I then have a duty of care under Regulation 5 of the Electricity at Work to meet, which is to ensure equipment is fit for its intended use, duty, etc. And by not doing this, you would be in breach of Section 2 of the Health and Safety at Work Act. Can you see what I've just done then? I've armor plated my early warning from just a contractual warning with costs to I'm discharging my duty of care. So I'm taking one logical argument and adding another one intertwined, which makes it robust. It takes away the personality. It clearly maps out the logic from a management system and an engineering perspective. By the way, you can probably tell I am really good winning arguments.
So I've done that, and I send it
Yep.
back to you as the client. What do you now do?
I sit there and go, bugger, because Mr. Watts decided to copy in my safety director.
Okay.
And the safety director is going to go, oi, Meenan, what the hell is going on here? You trying to save 20 grand? Don't be a skinflint. And more importantly, even if I turn around and say, yeah, thanks for that, do you know what I would do next? If somebody said, thanks for that, carry on regardless, I would turn around and say, another early warning. Please note, you're in breach of the legal duties. We will build your theme park. We will not connect it up. We deem completion of the theme park or the fairground or whatever the finish of our contractual arrangements, as we're not legally allowed to breach the law. So you can figure out how to do that last connection yourself. Please note, you will pay me 90% of the job, and copy in your lawyers. Who's got their asses covered? You have.
I've lost 10%.
Doesn't matter.
I want 10%.
10% based on unlimited fines and going to prison. By the way, that's kind of that legal duty bit being breached. So many people as well, and it's a really good point, Dave. So many people say the contract. What's in the contract? The contract will be argued with unlimited fines. Yes, unlimited fines. But the legal duty of breaching CDM, the legal duty of breaching Health and Safety at Work Act, includes unlimited fines and prison sentences. So when somebody says, do you want to have like Procurement Act or an NEC or a contract, or do you want to have health and safety law? Always pick health and safety law, because the fines and penalties are always bigger. So that's kind of scenario one, asset manager. Now, obviously, I'm going to add ISO and IEC reasoning into this logic. By the way, the reason I had JCT on the screen was JCT is a terrible contract that purely loaded to the client, and it's designed not to allow the contractor to do any float or any variations. You're just doing emails via your legal duty of care. There's no contractual mechanism for early warning in JCT. Anyway, right. So should we go on to the next one? John,
domestic.
You can talk about this one.
Right, this is scenario 2 then. And the lovely picture here, we've got some dodgy armoured piece where someone has just folded over the armoured bits and twisted around some bit of tape on it. And I can't actually see what they've done there. Anyway, it's a right mess. Earth connected on with a bit of old insulation tape and a horrible clamp, which is probably crushing the cable to bits and completely wrecking it and destroying it. Really obviously not acceptable. Pick a code, any code. Well, it's going to be a
well.
C2,
So let's pick
probably.
a code. Come on. So I'm going C2. What are you lot going for?
C2.
Yeah, I mean C2 is probably fine.
Ooh.
It's probably not going to set on fire this instant. It's not going to kill somebody if they touch it. So, yeah, potentially dangerous. Could crush the cable.
I think he's frozen, or he's just
sorry, me. No, I'm just trying to remember.
We haven't done one of these in a while.
I agree with C2. I was just trying to remember, what was the cable type? You remember that old clamps could be around the cable. What was that type of cable that was for?
Remember? That was the old. Go on, John. You tell him.
Yeah, that's the old lead PILC stuff where they the 951 clamps were allowed
Yeah.
a long time ago, and then they changed it so that they're not. But this isn't that kind of cable.
No, this is just an arms, isn't it?
Yeah, this is. The difference is that the lead ones are actually pretty robust. So the thing about, can you crush them and destroy them? In theory, yes, but you'd have to apply so much force that, you'd be literally twisting the screws off before that happened. But yeah, with these, it's obviously just soft plastic or some filler. So tightening down some big clamp around it is going to cause damage, and they were never actually applicable for this cable in the first place. So.
Yeah, I mean that's a significant amount of force on the cable, and the little what are those things called? Those little dividers between the cores and side. Those little things. Those will be squished, which means the dielectric strength of the insulation could be damaged. So no, it's crap. I just froze while I was trying to think of that old cable.
As a domestic electrician, it's crap, I think, is the most summary mindset you'll get. So you've got a very terrible use of a Tembi or BS951 clamp around some twisted back armoured in some weird Frankenstein attempt to do some sort of sheath armouring earthing. Never mind the bending radius of the meter, just the strain on the conductors of the meter switch. It's just a load of old rubbish. So it's a C2 every day of the week, which is great. Okay. So we've got it as a C2. So let's look at the engineering logic. So we've obviously got a legal duty of care. So if we start at the code breaker, or to quote the other side of the fence, electrical safety first one, because we know those two documents are totally tribal, even though everybody plays happy joy club. Then you've got in your specific logic, you've got IET guidance note 3, which will inform the inspector. So we're domestic house bashers trying to come up with our reasoning and logic. So we've used ESF, we've then gone to guidance note 3. We then use obviously the codes from BS 7671, which if you went all the way up would map into the harmonised 60364 electricity at work regulation. Anyone want to take a punt at a regulation here for EAWR?
Regulation 5, 8 and 10.
Yes, get in. Come on. You beat John Moore to the punch there, but yes. And then you've got the general duties of section 2 and 3, because when you're at work regardless where you are. And then obviously the essential health and safety requirements of any EU directives. Not that you'd ever be prosecuted under that, because if you did, you'd be committing genocide. And I don't think in a house you can commit genocide. Now, interestingly enough, that's the IEC world. But if I throw into the ISO management side of things, I would then look at ISO 9001, because most electrical contractors have ISO 9001, because they get more badges. So Construct Online and all the badge selling lot. Section 8.7, control of non-conforming products. So let's take the two-tier approach. So as a client, whether it's in a house, hospital, whatever, to add more logic, more robustness to your argument, you could do this. You could say it's a C2, it's mentioned in Codebreaker ESF. It's not mentioned, it's a direct breach of BS 7671, hence 5, 8 and 10 of electricity at work regs. Please note also section 8.7 of ISO 9001. So your management systems are in breach by allowing that to continue. Not just your engineering legal duty of care, but your management system. You've now doubled the impact of what you're doing. Now, this sounds mad, but I've actually done it in my career. I did some work at Heathrow, if I can be perfectly frank. And what was happening was the engineers were talking and no one was listening.
Yeah.
So what I did was I literally sat there and went, right, for every electricity at work regulation, I actually mapped the electricity at work regs into ISO 9001. This is about 10 years ago. And it was exceptionally powerful, as you can imagine, because now if you turn around and say you're a non-conformance to 7671, 5810, and your ISO 9001 certification is at risk if you don't do anything about this. Ooh, those who manage are not managing. They're failing to control non-conforming products. Can you see how it adds more gravitas, more weight to the argument? Someone tell me to shut up.
No, it does. It just creates more value for what you're doing as well.
Yes, it's more work, it's more stuff to learn.
Yeah. But
for me,
I did some work with a online streaming company, big N one, and and I ended up doing a lot of work about power and about productions in the middle of nowhere. And I found myself going down the venture of sustainability. So I then studied sustainability. I did this long-winded course on it, and you're looking at the different areas of sustainability, not just, energy, but like economic and social and all this stuff. Then I started to look at the impacts of ISO 14001, and that one as well. So many things you see in the workplace, you can actually support a company's obligations under that one, for the way they utilize electrical systems or the way they handle waste and things. There's all sorts of opportunities to kind of widen your usefulness.
So you imagine, Mr. Betteridge, now you do compliance, yeah? So can you imagine if on your compliance you applied the ISO requirement clauses? You've doubled the impact of your punch.
Very true.
Not many people do it. So hopefully people can listen to this and see it and go, there's a logic to this, or Paul, you're batshit crazy. No wonder people think you're mad. Right, moving on to the last scenario, unless anyone's thrown any more in there. This works. So these horrific images are from Sheerness in Kent. This is a complete and total failure of some ductwork system that was hanging in a school. And there was a fair few kids injured, as you can imagine. Can you imagine sitting in your exams and having that come down on you? So what would you say is the root cause of that? And if you're investigating it, what logic would you apply to it? Because I know what I would do, but I want to know what you guys would apply to it.
I'd want the data for the analysis of the weight loading, the safe working load for the supports, and what type of supports was it held on with, and the key reason why it came down.
Yep, that was my first thought was BS 8539. Has anybody done any sort of calculations or fixings? Obviously, it's not to concrete, but has anybody done a load calculation pack? Is there any shared services? What sort of materials were they using? Was there any witnessing and commissioning? Was there any consideration of external influences?
Yeah, and
vibration,
and the condition of the material you were fixing into as well.
Yeah. Was it because I've seen schools where they've hung it on gripple wire and all sorts, and you just think to yourself,
yeah,
given that, to quote Mr. Watts, that utilization of the installation and there being lots of vulnerable children, this is the sort of thing you'd want it to be bulletproof. Because when the service goes up, it never falls down because it hurts someone's kids.
Well, I was, I mean, not obviously closely related to kids, but somewhat hazardous. I went to see an apprentice doing observation on site, and he was working at a hospital not too far from us, having a huge extension added to it. I went up into the plant room where he was, and he was, big contractor, one of the big companies. He had to go through 3 different doors, 3 different roles, 3 different permits to get on. You got to wear all this crap just to walk around on the site. And I went up to watch him, and they were just single nutting using 1.5/8 for the ladder system in the main switch area, in the main ceiling switch area, which fed all the essential power to the new A&E that was being installed. This whole ladder system. And I said, at first I was like, oh, it's just single nuts, because I'm thinking of 8539 and all this stuff. But I noticed the screws that he was fixing, and I was like, is that temporary? So that's just what we've been given. And it was just like big penny washers and just like 1.5-inch screws and a red rule plug.
And I bet they were countersunk as well.
I was like, this don't make sense. And I didn't obviously raise it because I was just there to look at the apprentice, but I did mention to his supervisor to kind of look into it. And I think they've kind of done some kind of remedy, but apparently the whole thing's been installed that way. And the thing is, one of those fixings, you'll have that stress will be there. One fixing to buckle, it'll just be a domino effect. And if the thing's properly mounted, one fixing, it should be okay. The rest should be up. But when you've got such a weak fixing, the whole thing will just fall.
Can we start a campaign against countersunk screws? I honestly, I ban them. Yeah. I literally, if I see them on any of my jobs, I will find who's done it and I will give them the biggest talking to ever and say to them, I never want to see you using countersunk screws again. You're not a fucking carpenter, so don't use them. It's very few places you can use them, like or maybe on conduit saddles, stuff like that. Other than that,
yeah, exactly. Just conduit saddles and only a couple of maybe fittings that have that little recess in them. Like conduit boxes maybe, but thing is, again, some clients, you should ask that question because they may have specifications themselves. If they don't, then you can say, well, you should, and you can actually give them better information. When you can provide more value and provide better information with your client, they'll develop trust with you, and then you'll become the person they go to for other things. And then there'll be something in 6 months' time that they don't quite know. They'll go back to that person who gave them useful advice, and then you just grow. You get a reputation as a reliable person because you've done that work to expand yourself into ISOs, into these different management systems. And they're kind of just they are just behaviors that you can improve, and you can recommend your client improves their own.
Yeah. Yeah, you don't want to see me going off on one about countersunk screws, trust me.
I mean, you've raised this discussion with me, and we've kind of agreed about things like too much information, site blindness and all this stuff. When we put so many different stickers and so much information on places, it's very easy for it to get overdone. And that's it's a common sense discussion that needs to be happening. But in this case here, yeah. What was the cause? Do you know the cause for this? Or was it just?
I actually don't. I don't. We're never. It's one of them things that I don't even think's made it fully to court yet. To be honest with you,
I remember like 2 years ago there was a video at a car park. And there's water gushing in a long car park. I think I put a little video on it on one of my social media accounts, and it was a whole. I don't know if it was a ladder system or a tray system. The whole thing was down in the car park.
Yeah, it was. They fixed the purlings, and it was all gripple wire, and it just all one bit went. It all went.
Yeah.
I think one of the things that desperately needs to be spoken about in our industry is fixings.
Oh yeah.
But I think it's a conversation that people aren't going to want, because now you have everything proprietary. I mean, if you speak to the guys at Midfix, they'll say to you straight, proprietary fixing system is one that's type tested together. So when an electrician goes to cities and they buy a box of Zebs, a box of nuts, go to Rexels, buy a box of washers, put it all together, no one's type tested that for suitability.
No.
Some of the penny washers now are awful. You can bend them with your fingers. They're that value engineered.
When I was running, commercial company and on the tools, I'd always avoid having to go anywhere near steel as much as possible to fix with steel. These days, people jump on it, and I go, "Well, how are you doing that?" And I look at the ways that they have these kind of nuts that they spin and they wedge in, and I'm like, oh, some of these things that are fitted into steels now.
Yeah, wedge nuts. Yeah,
I'm like,
Hilti.
wow, okay,
Midfix.
yeah. And I'm like, there's so much new stuff, but I that stuff's like, there's some stuff back when I was on the tools, but there's so much new, and I don't know. Sometimes I think that the load of them, you can't put too much weight on them, but some of them are pretty good.
No, some you can swing off of. To be honest with you, dare I say this out loud? When we put up Unistrut brackets, we do actually make the apprentices swing off of them.
Yeah,
probably shouldn't say that out loud, but I've literally swung off of trapeze brackets and also single points of failure. The amount of electrical installations I see where they're just a single point of failure, whereas I was always taught 2 fixings, everything 2, no single point of failure. I don't understand these tray, them little weird hook things that you can hang tray on, light duty tray. I find that just despicable. I hate it. I would never allow that to be installed anywhere near my railway ever.
Well, again, it
point of failure.
I remember it's the same thing like with conduit systems, where you put in the conduit system and then they let the box kind of hold it into final positions. They put the box on, then they put that bend in, and they let the box hold it so that tension's always there, instead of actually just letting the conduit just rest at the right angle. And that you have that one fixing, which if it does go, the whole thing will just then, spring out of action.
And we don't drill conduit boxes, by the way. It's another little message. You don't drill conduit boxes.
Yeah. You find electricians that don't drill conduit boxes. They all do.
No, I know. And I don't allow
drill a hole and they get the conduit in it and they just bring it down so it's hot, so the level's line.
None of my conduit. All my conduit is done on distance of hospital saddles, and they're absolutely banned from drilling holes in the back boxes. 150mm saddle from each bend, each set, etc. That's where all the weight's held in the saddles, not in the conduit system. You drill a back box, you compromise the integrity of it. It's pointless. And yes, in case you wonder when I'm snagging, yes, I make them put a 3mm grub screw and an IP washer in the back box of every single one. detail.
Yeah.
Just moving on very lastly, so there's lots of information and guidance out there, tons and tons and tons of it. I could reference the Engineering Council, but I found these two books that look quite interesting. The Thinker's Guide to Engineering Reasoning and Ethical Reasoning. So there's, that ethical mindset you need to have as well. Am I doing the right thing? Do I need to speak up now? Yes, you do. I think it's fair to say, we are most certainly an independent voice in the UK electrical industry, unsponsored, unfiltered, and probably spoken about behind many a closed door. But that's fine because we can sleep at night. I won't go into the key concepts. I think I'll just kind of stop that presentation there. Guys, what additional thoughts or things would you like to bring to the engineering reasoning or logic table? I'm going to start with Mr. Ward.
Yeah, on that last scenario there with that collapsing item, one thing which is important is to check that the design was actually valid, and then most importantly, check that the stuff was actually installed according to the design and it didn't get somehow changed along the way and it was altered in ways that may have resulted in it falling on the floor. And if people want to look into that in further detail, you can go and look up a fairly famous case of design being changed in what seemed like a minor way, which is the Hyatt Regency walkway collapse from 1981, which was a classic case of it was designed properly, but when it was installed, a tiny change was made to how the walkways were supported, and the end result, it collapsed and it killed a load of people and injured a load of others as well. So what might seem insignificant if we're installing something can end up being very significant in terms of its, say in that case, weight loading and whether it's actually going to stay in one piece or literally collapse and kill people. So designs are valid, and obviously you need to make sure that the stuff itself is actually installed to that design, and if it has been changed, make sure that whoever changed it did actually change it for good reason and they knew exactly what they were doing.
See, it's quite interesting. So that CMS collapse that happened on that famous video, I was talking to an electrician who was on that job, and they were basically drilling the purlins. Now, over the last 20 years of my career, when I've done anything where people have drilled purlins, they've gone to the structural engineer, and the structural engineer's gone, yeah, that's fine, you can drill them. But the structural engineer may not have done any of the MEP load calc pack. And they'll just make an assumption in hearsay because they're not necessarily being paid to take responsibility. And this is exactly where John has said those disjoints happen. So you've got, a designer going, what do you want to drill a hole for? Well, I want to drill a 10 mil hole for some gripple wire. Oh, okay, yeah, that should be fine. Yeah, what are you hanging off it? Oh, just some lights and stuff. Oh, okay, great. And then they ended up putting like 3 tons of ladder racking and trunking and conduits and lights and cabling across purlins that are, say, 10 meters apart. And you're like, wonder why this is all collapsing. I mean, Christ, when I was an apprentice, we did, and I won't say the location, but we did a ladder rack off of gripple wire off of a ceiling where we drilled the purlins. And I can tell you now, as we were adding the armoured 120s, 185s, 95s, as we were adding these armoured, we'd go in the next day and get up on the ladder rack to pull the next cable and go, why is this lower? And it was lower because the gripple wire couldn't take the weight. And it was literally getting thinner and the ladder rack was lowering. So we were having to go around during possessions of this railway depot and try and lift it up and use the little key to get the gripple wire to go up. And then my governor went, yeah, probably should put some extras in.
Yeah.
Does that come down to sort of a design where you could, and I don't know how many people do or definitely should, be going to the manufacturers and finding out the weight per meter for that cable, how many cables going on it, and how much strength and weight the tray or ladder can take, and then build from that to the containment to the supports.
That interests me because the only company I've seen, and this is not an advert, Midfix, they've got an online system now where anyone can go on and do a load calculations pack. And it will then, if you tell it exactly what you're doing, you're intelligent enough to have a conversation with it, it will give you 3D drawings, indicative drawings of what you're trying to design. So you can visualize what your intent is, put the distance between fixings, fixing methods, all that sort of stuff to give you compliance to 8519, 8539, etc. So the trouble is all that will be that will all be based on proprietary tested fixing methods, not your go and buy some Gribble from Rexills, go and buy some Unistrut from Hobby Homes, go and do this, whack it all up. Oh, I think it's 200 kilos a meter. Oh, by the way, design change 2 years later. They've gone from 35mm 5 cores to 185 4 cores. These things happen. They get missed. Change control, it's really important. And that's one of the things that you've got to, and this is where engineers earn their money, making sure somebody doesn't make a really bad decision, you know, and that you're meeting that management duty to discharge your health and safety in your engineering logic and also the management systems.
We even covered that in our large scale EV course. If there's any deviation or adjustment, you must go back to the original designer and get all of those things back in order so that you discharge your duty as any installation or commissioning engineer. The last thing you want is some change of decision to kind of sit on your lap.
Yep. But then crap designers
change.
Will turn around and go, well, you tell me. And that's when you know they're a crap designer, and that's when you have to remove them. I had a designer turn up on a job, and I said, right, the D&O cupboard's over here, and his first response was, what's the D&O?
Yeah, you need to find a new designer for that one, mate.
And that was a very large, robust design house in the UK that charged many hundreds of the king's pounds per hour. And then they just go, well, just put it on a TQ and you tell me. And you're like, no, because when I do that under CDM, I then become part of the design authority. And I know under the basic arguments there is what's the standard? I should have raised it earlier. There is a BISRIA guide on allocation of design responsibilities. It's in our drive, and it basically says there's a great one-liner in it that says the installer is always responsible for validating the design, the design's buildability. So if you can't build it, you have to legally tell them, because that, again, another document will be used to beat you. You have to legally tell them.
BISRIA is one we don't obviously say about that much. I've got some thermography stuff of theirs.
It's a really good.
It's a good.
It's a really good old. There's some really good resources in there. Phenomenal resources to watch. I think BISRIA are massively underrated, but and it kind of you then start to realise how weighted it is against you if you go and install something without the proper designs. You go and install. I think, as I said to many people, do you have your brown trousers on today? Why? Because you're writing checks you can't cash. You know, it's squeaky bum time if you don't have all your ducks in a row, and if you haven't got your logic on. What can my defence be today? What can it be tomorrow? Not will I get away with it because I always have, because that's just stupid.
Well, you say it's reputational damage. It just takes that one time, and your reputational damage is gone.
Well, look at the idiots who did Grenfell. Sure, they went around winging it for ages. Hey ho. Right, I think we'll end it there. Final thoughts, Mr. Watts. Then we'll go to Mr. B and then JW.
I mean, we see the value in learning things beyond what we're told to learn. We see the value in looking outside the box. We see the value in, even if people may say we're like, a bit self-indulgent with what we do,
Well, you know what my response to that is?
Comments that we may receive, but fundamentally, it helps. I mean, in our own, this is just a thing that we do, but in our own workspace, we benefit from it. I benefit from it in my work, and it's not whilst it's interesting to learn more, and you call it a hobby, trying to learn more. I don't like reading books as a hobby. I like doing other things as a hobby, but I find that they actually improve the value in what I do with my work, and so it helps me develop and helps me relate to clients I've got clients in food, I've got clients in automotive stuff, I've got clients in medical machinery, food picking, and all sorts of places, and there's all sorts of different areas, responsibilities and things to learn. But if you have the willingness to learn, the willingness to read, I've got piles of rail stuff and all sorts of things. If you're willing to learn and open up and read, don't keep everything in your ring-fenced regulations world, you'll find that you'll offer more value to your client, because your client has an awful lot of other things. We talked about this in the asset management webinar that we did. There's so many other things the client's thinking about, not just 7671. And if they invite you to engage with them as well, you've got 7671, you've got this NIC thing, whatever. But if you go, well, if you just speak in a language where they can go, oh, hang on, this is different. This is different. I'm understanding the legislations more. I'm understanding the point of this work more. And they're talking about this and they talk about that. If you can add the value, then it helps everybody. I've got like, I'm the same in the training space. I've got all sorts of guidance books here. I'm reading up on heat pumps because I found that interesting. This is an old book I just found next to me, from the fire stuff I've done with the rail, the old Losted, the Fennel report. There's so much information out there. Say JW's just picked up his example. It's just a case of expanding your understanding and archiving a way to reference it later on, and being open to learning more.
Mr. Betteridge?
Yeah, I think as electricians, we start off really looking at engineering logic in the wording of judgment. And we usually find that within BS 7671 in page 2, where it goes its own skills and judgment to how we apply the intended regs, how we interpretate them, or the guidance note says the same sort of thing. I think the problem with us electricians sometimes is we get a bit of an unconscious competence. We get kind of we know it all kind of approach. We don't need to learn anymore. We've got these lovely certificates and cards that say we're electricians. We don't have to hold anything else. We know everything off the back of our hands. And it would be good to be on site and have an engineering logic. You might be able to stop that cable going in. That may be the wrong side for certain reasons, or the environment's wrong for the fixings. I think we just lost a little bit of our engineering judgment, as I said at the start, through maybe the way we're trained these days. Maybe the loss of written examinations have made it a little bit like we've lost our engineering judgment. And I think we need to get that back. And as Dave said, we need to just continually keep learning, keep doing our CPD, keep basically learning as much as we can in all different things. I find interest in all different subjects in the electrical industry, and I tell you, I'm never fully qualified.
Indeed. Mr. Ward, can you follow that logic?
Yeah, I think just to add a final point there is that if you've been doing something in a particular way forever, stop and think about, is that the correct way to do it? Is there a better way of doing it? Because it's very easy to do something in a particular way. Oh, we've always done it this way. We've done it this way forever. This is the way it's done. That's all there is to it. And it might be valid, but stop and think, is it actually valid? Is there a better way we could do it? Is there a different type of materials we could use? So don't just get stuck in a rut and doing the same old things all the time. At least occasionally just have a look and think, yeah, is there a better way of doing this? Can we improve this? Do we need to be doing this at all? And just think about what you're doing rather than just going in and doing it because that's how you've always done it.
Yep, don't disagree. Right, I suppose we should probably end this. So we will be back after the summer or whenever. I suppose it's the ever-growing mystery of when's the next one. The next one will be whenever we want. I'm still doing the fixed radio stuff at the moment until I get bored of it and stop. I'm also going to be at that Fix Fest August, whenever it is. It's the week of my birthday, but anyway, I won't be watching music. I'll be playing with John's rig on diverted neutrals and stuff, and hopefully also during the summer the diverted neutral current book will be out. Maybe, but that'll be our next one where we can actually do a peer review of it or talk through it as a little update, because it's worthwhile putting an update out. And I think next week Napit are doing a diverted neutral current webinar.
They are. I've registered to it.
But so have I. And they've been chasing me for this book.
Have they? Well, let them wait another week or two, eh?
I might do, actually. I think I will. I'll just wait. I'll send it to them at 6 o'clock the day it goes on.
I think Steve Devine's the guest speaker.
I know.
So,
well, yes.
Go and buy his YouTube video. He'll be well prepared.
Yes. Right. Other than that, thank you very much for watching. Thank you very much for watching. Thank you very much for listening. Until the next one, take care of yourself and each other. Bye-bye.
Bye-bye.